let's dive right into the next part of the program. So what we've got here is a panel of founders and CEOs of companies building robots for unusual workplaces. And that's probably not the way they would actually describe their companies. They're building stuff that helps with agriculture, that helps with solar energy, that helps with hair restoration, that helps with actual problems out in the world. But the way we framed the event today, we wanted to kind of bring you a variety of companies that are building things that change the way we work. So I'm going to, at least start by asking these gentlemen to maybe talk about the way their companies are changing the experience for the people who are actually out in the fields, the people out building the solar arrays, the people moving plants around, the people working in clinics. So we'll start from there, and we can branch out and go in many different directions. But what I'd like to do is introduce these guys and ask them to start out by spending 3 to 5 minutes telling the stories of their companies. So why don't we just kind of go across the room from here to there and start with Wasiq Bokhari from Qbotix, which is doing robots for solar energy.
That's correct.
Yep.
So my name is Wasiq Bokhari. I'm the founder and CEO of Qbotix. My background before starting this company was I used to build solar farms. And solar farms, we used to build these large, ground-mounted systems. They require two things: low cost and high reliability, two seemingly contradictory things. So how does robotics come into this? But basically, one of the learnings that I had during the experience of building solar farms was that if you look at a solar power plant, there are 4 basic elements of cost. You have the silicon part, which is the modules. You have the copper part, which is everything electrical, inverters and wiring and so on and so forth. You have the labor part, and then you have the steel part, which is the mounting system that you put the panels on. And whenever we think solar, we think silicon or solar panels. For ground-mounted systems, the cost of solar panels is only 1/3 or less of the cost of the solar power plant. So the cost of the copper part is about 1/10. The cost of the labor and the mounting system is about 40%. So everybody thought that was not interesting, it's boring business, but that's actually precisely where you need innovation. So our collective thought process was that let us find a way in which we can decrease the cost dramatically, number one, and number two, boost the energy production of the solar power plant, and that's where robots come in. So we have a robot where a single robot can control 1,200 solar panels, or almost 1/3 of a megawatt, and move them so that they follow the sun. And by doing that, the same panel produces 30 to 40% more energy. And that lowers the cost of electricity that is produced by the same solar power plant.
And you've got one of these out in the lobby, right?
We have one out in the lobby, and more than happy to talk in more detail about it.
And basically, it runs on a track in a circle, right, in a loop.
Yeah.
And as it goes past each panel, it slightly alters the direction so that it's tracking the sun all day long.
It's tracking the sun. So we use the word robot because that's cool and sexy. But when we design it, we think of a mining truck on a rail, because it really has to withstand very harsh environments in the middle of the desert for very long periods of time. The typical lifetime of a solar power plant is 25 years. So this thing has to exist and operate autonomously and intelligently out in the middle of nowhere for very long periods of time with very low maintenance.
The alternative would be to have a separate motor on each panel, right, on each collector?
That is correct.
Right. So, and you're saying a single robot can go and do the job of 1,200 separate motors?
That is correct.
So you're putting all those motors out of work?
We're putting all those motors out of work.
All right. I thought so.
But they don't complain.
All right. Okay, so Ian Sherman is here from Dolly, and Dolly is reinventing what it means to do technical shots on movie studio sets. So Ian, can you take it away?
Sure.
All right.
I should say I'm not the founder. I'm head of software development at Dolly. We're in San Francisco. And we're building tools to bridge industrial robotics with creative applications. So our first foray into that has been in the world of film. We spun out of a creative production company called Autofuss that began by using CNC mills for camera control of simple product photography. Quickly outgrew that, bought some Fanuc robots off of eBay, and started seeing what we could do with 6 degrees of freedom instead of 3 in the scale of 15 feet of reach.
A Fennec robot is one of these big industrial robot arms, right? With
Right.
Several joints. Right.
Yeah, so this is the same kind of robot you'd see for welding applications on a car assembly line or palletizing applications. And at this point, we have about a dozen robots. We have been involved in everything from feature films to commercial photography. And we're finding that this is a really appealing platform for highly technical filmmaking. So in the case of a shot where we need to coordinate not only a camera move that's repeatable for multiple passes, but we might need to coordinate lights, actors, props, down to the millimeter. This is a kind of shot that hasn't been previously possible. And I think the really interesting thing is that we're leveraging commodity hardware to make this all happen. So we're really starting with popular industrial robot manufacturers' models as our hardware base, and not investing there. We're investing in the software tools on top of that. And for any of you who've used these robots, you know they're really painful to work with. So we're trying to integrate with tools like Maya or Rhino, tools that are familiar to people in the creative industry. And we were talking earlier about the problem of retraining. I think from our perspective, we're interested in not even requiring retraining, but using tools that already exist, enabling people to start using robots for augmentation. And another idea that earlier discussions brought to mind was, what kind of workforce are we talking about here? I think the creative worker is a significant section of the economy that has not been brought up in the context of robotics, and we're interested in enabling the furniture designer, the jewelry maker, the filmmaker, and we're building tools to make that happen.
So basically, you can feed a Maya file or an AutoCAD file straight to your robot. You're buying sort of off-the-shelf commodity robots in a way, but the special thing here is the layer of intelligence and the connection that you're building back to these creative tools.
That's right. Yeah.
Okay. All right. John, can you tell us about Harvest Automation?
Yes, good afternoon. My name is John Kawola, and I'm with Harvest Automation. We're a Boston-based company, and I am also not the founder, but I'm the new CEO. I joined about 4 months ago. I actually came from, there was a lot of talk about this today, but I actually came from the 3D printing industry. I was in 3D printing for about 15 years and was the CEO of a company called Z Corporation for the last 5 or so. And as things go, when companies become successful, then they're acquired. So then I moved on and very much looked at robotics and saw robotics in a way that, that 3D printers, when we first introduced 3D printers into enterprises 10 years ago, it was about productivity. It was not about replacing people. It was about productivity. And I very much see robotics in that same way. So what Harvest is all about is looking at the very difficult work in agriculture. It was brought up earlier in the afternoon that a lot of agriculture has been automated. That's really not true. So there's certain segments of agriculture that have been automated. But I asked the people here in California the last time you actually saw a John Deere combine in California. The crops in California are fruits and vegetables and tree crops and nuts and horticulture, heavy manual labor, difficult work. People over the course of the afternoon have talked about work that people shouldn't be doing, or really in hospitals or other places. Working on a farm, doing that type of work is brutal work. I spent a half a day a few months ago doing the work to see if I could do the work. And I'm a soft office person like most of us here, and it's just really difficult work. And the change in demographics out there, the net immigration from Mexico is now 0 across borders. People are, we talked a little bit about manufacturing jobs. As much as we'd like them to come back to this country, net over the last 15 years, they've moved south. So there's good jobs in Mexico for people who work in Mexico. So less people coming up to do the farm work that's needed. And so that's really what we're all about as a company, is developing smart mobile robotic solutions that do a lot of the manual labor tasks that are left in agriculture.
Okay, thanks. I want to take one quick second to do a technical shout out here to the InTouch Health guys and the iRobot guys. We're running about 20 minutes behind. Okay, all right, sorry about that. All right. Jim, can you tell us about what's going on in the world of hair restoration, a field I may eventually want to investigate for myself?
Well, in fact, when I look around, I see quite a few candidates here. But let me first kind of describe why we exist, and because it's from a different perspective, and one that everybody here, sooner or later, will certainly be involved with. And what I'm specifically talking about first is surgery. And even here, would people trust a robot to do your surgery? I mean, would it be good? Would it be better? So it really kind of starts with the concept of taking something that, you know, as we know, the top people in the world have certain skills that you cannot teach the next person. Eye-hand coordination, steadiness of hand, the ability to do these things. And I guess a question for all of us is, can a machine do that as well or maybe even better? So if you start thinking about it from that perspective, and then what you want to do is, with medical products, and especially surgical products, you need to define a specific application. It doesn't work to have a robot that can do 10 things. It needs to kind of hone in on one thing and own that specific application and procedure. And for hair restoration or hair transplantation, it is this procedure that takes all day, it's tedious, monotonous, it's not scalable, it's very invasive, it's got all these issues, but yet people have tried for decades to automate it, and nobody knew how to do it. And short of a little robotic arm doing these tedious, monotonous motions hundreds and thousands of times, there probably is no way to do it. So the concept, you know, very simply is, if Wade is the best surgeon in the world and has done 10,000 cases, and I'm a rookie and I've done 0, and I get this system within a couple of months of training and support, he and I are at the same level. And what happens over time? With smart algorithms, improvements, et cetera, now you can begin to do something that the best in the world really can't do. And now you make that scalable around the world for every doctor and every patient basically can benefit. And the other thing that I would mention that for me was very interesting today to hear the discussion, ongoing discussion about jobs, increasing jobs, decreasing jobs. But when you look specifically now with most medical robots, and especially in surgery, the market research shows that the majority of patients prefer a robotic technology. And part of this is Intuitive Surgical blazed a trail about a decade ago and everything, but actually most people prefer a robotic technology to do surgery, and there's 4 or 5 of them out there as well. And when you ask them, it's very simple. The robot doesn't get tired, it doesn't have a bad day, and it can do all these kinds of things. So for me, I think we should start, and I think even shaping the argument even stronger. It's political, it's economic, creating jobs, yes, no, blah, blah, blah. However, let's really kind of look at what we do that is unique and truly enabling and tell that story. And I think we should frame the argument and I think own the argument much, much stronger.
Jim, can you, though, spend just a minute explaining what the robot does and why it's better at this task than a human surgeon?
So what we do, we have cameras, we have an imaging system, it's an image guidance system. We look at the back of the head where you have hair follicles. We have algorithms that look at every hair follicle, good ones, bad ones, angles, thickness, et cetera, and then we basically do a minimally invasive technique where we remove the hair follicle one at a time. And that is something that surgeons cannot do today. They have to do a very invasive, very painful procedure, and it really enables a brand new procedure to be done.
Okay. What I'd like to do is ask each of you to talk about how you infiltrate the world that you're trying to infiltrate, given that there are people who already do a lot of the jobs you're talking about doing. There are people who do hair transplantation. There are people who work in fields. There are people who plan and execute complicated movie shots. And there are people who build solar arrays and operate solar arrays. So who is your customer, I guess, and how do you convince them that a robot is going to improve their life and not just put them out of a job, right? So talk about how you win acceptance in your particular business. And why don't we go down the row again? Can you start?
Sure.
Can you start? Thanks.
So for us, actually, there has never been a question that we are going to displace people. Because when solar farms are built, ground-mounted structures, the same laborers, the same crew will install either a robotic system or something else. So we are not taking their jobs away. So as you said earlier, the only jobs we are eliminating are those of motors, and they don't complain. But if you look at a solar farm, it is essentially a financial instrument, right? The two major customers that we have, you have the equity investor in the farm who's interested in the IRR of that project, and we have the bank who has lent the debt to the, and they just care about the coverage ratio for the debt. So because we increase the production of the solar farm, we increase the revenue of the solar farm because everybody is paid in some cents per kilowatt hour that is generated. Therefore, the economics of the project are better. So as a result, it's a very simple sell that, look, you're just going to make more money. Not only every year, but over a 25-year period, you'll make a lot more money. So that's the first argument, and everybody gets it. Now, the resistance we get into is that people in the solar industry, they care about long-term reliability. So we have to show that our system will operate under harsh conditions for a very long time with usual minimal maintenance. And that is also our core competence in making robots that are not too expensive, but are also minimal maintenance, very high reliability, long lifetime systems. So that's our strength. So between the combination of that and some other, other things that we have to do in the solar industry, through warranties, warranty insurance, and a bunch of other instruments, we can bring comfort to our end customers.
Okay. So it's never a hard sell, or is it occasionally a hard sell?
It is a hard sell because you're telling people to adopt a new system that has not been proven before, and for that reason, so we have 4 commercially operating systems right now, 3 in the U.S., 1 in Japan, and we have multiple more that are in the process of being planned or constructed. So it is a stepwise process for us to build these at increasingly large scale, and once you demonstrate that these operate, they give the production benefit and the reliability that we promise, then you're good to go.
Mm-hmm. Okay. Ian, the story behind Bot and Dolly is a little bit different in that it kind of came out of a collaboration, right? So there were filmmakers who needed to be able to do this kind of shot, and that's why the technology exists now. So maybe it's a pull situation more than a push situation, but as you get out there and try and sell this technology to other filmmakers, do you run into any resistance? Do you have people asking, why should I hand my job over to a robot?
Well, I think one thing that we're in a very privileged position to be in is that the product we create is sort of in itself a marketing tool, and so film is the way we tell stories, and we're lucky that we're getting to make films and then use that product again as our sales tool. It's interesting seeing how people react on a film set because industrial robots are not something that the layman encounters really ever, and I think that's going to change. But for now, people are very curious, and this theme of intimidation has come up a lot today of the sort of the threat of the cyborg or something. I think I see a lot of research about more human interfaces, more capacity for emotion. And I think that's one part of the equation, but I think an equally large part of the equation is, how are we controlling these things? I think the black box that robots are to such a large part of the population is a large part of the intimidation. And so the more we can do to expose people and give them tools that are actually usable to put the robots at their command instead of as the antagonist, I think that's how we're going to gain favor. People joke about being replaced as a cameraman, but when they see a robot moving at 4 meters a second and repeating it to the millimeter, they can't really argue. So we're kind of we're working to make new shots possible more than we're working to recreate what humans are already good at.
Okay. John, what kinds of situations, which types of agricultural operations do you fit best into, and who's doing those jobs right now, and how do they feel when you show up?
Right. So the first market that we're choosing one specific market to enter first, which is the horticulture industry, which is actually a pretty big industry in this country. It's about $17 billion a year in wholesale dollars. So this is actually anything in a container. So all sorts of shrubs and bushes and roses and a fair amount of food crops as well. And the business, so our customers are the business owners. So these are farm owners, and the size of these farms are relatively large, anywhere from $10 to $100 million farms. And the early adopters here are the people the farms that are under significant distress to get enough people, to get that extra 20, 30, 40, 50 people, especially during the seasonal work that they often deal with. So some of these early adopters are very much, it's not about replacing labor, they don't have the labor. And agriculture is a type of industry where the biggest cost is the asset, the land that they own. The second biggest cost is the labor. And then it's a huge loss if they can't get the labor in that 1 month window or that 2 month window that's most important to them. Because if they can't do what they need to do, that money just goes right down the drain. And so, that's some of the early adopters who have just come to us and said, I have to be able to supplement my workforce in a reasonable way to get the work done. The second thing that we're starting to realize, and we're only a couple months into this, is the farmers are using the robots for things other than they intended, for other work that they actually don't have people do. So they're able to do things that they generally have not gotten time in the past they wouldn't do, just because they wouldn't have the people.
Like what?
Well, there's different operations in nursery and greenhouse where you move plants around to really optimize growth. And in a perfect world, you like to move them 5 times. But when you only have a certain number of people, you only move them 3 times. But when you have the asset, when you've already bought this asset, it's not an incremental cost to use it for the 4th and 5th time. So they start using it all day, but then choosing, we'll also use it from 6 o'clock at night to 12 o'clock at night. So that's starting to be an upside where they realize they used to have a cost, might have been a labor cost. Now they have an asset that maybe is supplementing that labor cost, but now they can use it for more. And in agriculture, like a lot of industries, if they can increase quality by 5 or 10%, they increase yield, they can sell the product for more, it's all upside. And that's how they see using these technologies.
Okay. Jim, who's your main customer? Is it a clinic? Is it a hair restoration clinic where the argument is that it's going to increase their productivity, they're going to be able to treat more patients, so maybe for the practitioners running that clinic, it's a no-brainer?
Yeah, it's definitely not a no-brainer, and I think, as we all know from all the various speakers, I mean, what we're really talking about is change. And, some people bury their head in the sand, other people adapt it and run with it, and it takes time, and there's various programs. For us, you really need to have data. So you need to be focused on some real data so it's not just you and I arguing about stuff and seeing who shouts the loudest. So because we are a surgical device, we're regulated worldwide by various agencies. Here it's the FDA. So, you have to go through a rigorous process of safety data showing this thing is safe, doesn't hurt people. And also, you have to show the efficacy. It really works the way the thing is supposed to work, and you get the kind of results and all that. So it really starts with having that kind of data as a foundation, and you build on that over time. But yes, the basic customer is a dermatologist, if you will. Some of those are doing hair. Some of those like what we're doing. Most of them are struggling with it, frankly. Because, again, if you are the expert and you're the artist, you feel like what you do, no machine can ever duplicate that. And in reality, of course, it will be even better, but you have that resistance, whereas usually the younger people that may not even be doing it pretty easily say, hey, this is a way that I can get in the game now. And I can become now the #1 guy in town as opposed to the number 3 or 4 right now. But all these things take time, take a lot of work, and you have to really focus on execution.
Okay. I think what I'd like to do with the last 5 minutes or so is ask you guys to speculate about the future. So, we're talking about 4 very specialized types of workplaces here: farm fields, movie sets, energy plants, dermatology clinics. Can you see yourselves moving into adjacent fields? And what else might your robots be capable of doing? And what do you feel like you're learning about how to sell into your existing market that might help you when you're ready to sell into an adjacent market? Jim, do you want to start?
Certainly. Yes, there's no question that our core technology has numerous medical applications. It's part of why we have a full-time patent attorney and we file applications each month and all that. And really what we have, at the end of the day, we have a robotic delivery system that could have lasers on the end of it. It could have various other kinds of technologies there as well. So yes, definitely much broader than just one specific application.
And do you feel like you're figuring out how to deal with surgeons and decision makers in the healthcare system so that the next time around...
That same process. It'll be the same process, basically.
Mm-hmm. And dealing with the FDA, of course.
Right.
Yeah. Right. John, could you guys come
Yeah,
up?
I mean, agriculture, we're focused on a first segment to enter agriculture, but agriculture is this enormous space with all sorts of different subsegments. so the way we think about expansion and other ideas for robotics is the first applications, and for a lot of robotics applications, it's about material handling. It's about moving things around in an efficient way. But when we look at agriculture, there's 3 different ways that companies are using technology to help improve agriculture. One is biotech, so chemicals and seeds and things like that. One is infotech. It was referenced here about drones and understanding information. There's lots of companies out there that are using that information and allowing farmers to make better decisions about their crops. And then there's the automation side, which is material handling. But we certainly see that mobile robotics can play a role not only in material handling, but also in the other 2 categories. So in biotech, in information gathering, these are all applications that we see a mobile autonomous platform to be able to do well.
Great. Ian, you guys are already using the arms to build sculptures, right?
Mm-hmm. Yeah, so we built our platform for a particular feature film project about 2 years ago, but since then we've found interest in a lot of adjacent fields. So we've partnered with the UCLA School of Architecture to commission one of their new graduate studios with robotic fabrication technology. We're applying our tools to some problems in furniture design. And maybe most interestingly, we're finding that some of the lessons we've learned from the creative industry are sort of backfeeding into ideas in traditional manufacturing. So we're starting to look at what can we do if we take a film technology like motion capture and think about how we can use that on an assembly line for rapid retooling, rapid demonstration of tooling paths, things like that. So we're in this position of dialogue. And there's one other, oh yeah, so, and I think the other voice that we're trying to be a voice of design-oriented thinking in robotics, and people have been talking about this throughout the day. I mean, we're all benefits of sort of Apple's design-first approach to the PC, and I think there's need for a whole bunch of people working on this problem in robotics.
Absolutely. And Wasiq, you're making an unusual robot that goes around on a track doing one job all day long. Is that generalizable? What else could it, what other ideas do you guys have?
Sure. So first in the solar, industry itself, so large existing, solar farms, they span hundreds of acres, could be square miles. So now imagine these things have tens of thousands of solar panels, in some cases many more, and you could have a fault, electrical or mechanical fault. So there is, some lucky guy on a golf cart on a hot sunny day driving down a mile of rows of solar panels. So sounds like an ideal job for a robot to help him with, right? So that is the next stage where the same robot which rides on a rail has the same reliability and toughness, characteristics, can do 24/7 monitoring of these solar farms. And then we step back, we say outside of just looking at the health of solar panels, you can look at site security. So are there any people coming in, stealing your panels, stealing your copper wiring, and so on and so forth. So that's just all in the solar industry itself. Now outside of that, if we have a tough robot that can survive a very long life, low maintenance in outside environment, you can use it in multiple other industries. Maybe some part in agriculture. We have had people come to us where they would like to use our robots in tunnels, subterranean tunnels, to do inspection of tunnels, maybe rail inspection, and so on and so forth. It's the same system, same robot, same chassis, just a different instrumentation on it.
Yep. So my thesis is we're going to see a repeat of the PC revolution, where PCs colonized the back office, the bookkeeper's office first, and then very quickly kind of spread to all sorts of other roles in the organization. And once you get robots implanted in an energy plant, the number of jobs people can think of for these robots is just going to keep multiplying, right? So they're going to spread virally in a sense. Yeah. All right. Check out their websites, Qbotix, Dolly, Harvest Automation, and Restoration Robotics. They all have great websites, and they all have videos showing their robots in action. So I would encourage you all to check those out. And please, I'd encourage you to give a hand to these panelists. Thank you.